All right, Algebra 1A students. Welcome to part 1 of Lesson 3.6. In today's video, we're talking about compound inequalities. A compound inequality consists of two different inequalities, and in this video, we will be focusing on inequalities combined with the word and. Okay? Combined with the word and. The graph of a compound inequality with the word and is the overlap of the two graphs that form that inequality. Okay? For example, we could have x is greater than or equal to 3. So we put a closed dot at 3, go greater than or equal to 3. And then we could also have x is less than or equal to 7. We put a closed dot at 7 and go less than. So the and inequality combines those two graphs and talks about the overlap between them. So 3 to 7 is an overlap of both of these graphs. So that's the graph of the and inequality. An and inequality is always graphed with two endpoints. Okay? Always has two endpoints. And shade in between. Okay? Always two endpoints, we always shade in between, every time. Now, we can write an and inequality as one inequality. We can squish the two together, because if we look together at this piece, x is greater than or equal to 3, we should know we can also write that as 3 is less than or equal to x. And then the other one says x is less than or equal to 7. So instead of writing these two different inequalities, sometimes we just put them together and we say 3 less than or equal to x, which is less than or equal to 7. Okay, this way we only have to write the x once, because it's now in between 3 and 7. X is in between 3 and 7. Okay? So, in your homework, in your practice problems, I will ask you to write the inequality that represents the number phrase. Okay? And here we have all real numbers that are greater than -2 and less than 6. So, x has to be greater than -2, and x has to be less than 6. I can squish these together quite easily, right? Because I can just flip this one around and say, well, -2 has to then be less than x, right? These two are the same thing. So now if I put these together, my compound inequality would say -2 is less than x, which is less than 6. Okay? And then to graph that, we just treat each inequality symbol individually. This one here at the -2 should be open, because there's no equal to sign. And the same thing on the other side. The 6 should be open because there's no equal to sign. And the graph is always the two endpoints shaded in between, like we did here. Okay? The other thing I'm going to ask you to do is solve a compound inequality that involves and. Okay? Two ways we can do this. One, we can split it up. We can say, let's say this one says -3 is less than or equal to m minus 4, which is less than 1. So I can say, well, -3 I know is less than or equal to m minus 4. In order to solve this inequality, I just have to add 4 on both sides. Right? And that gives me 1 less than or equal to I could also take the right half of this inequality. It says m minus 4 is less than negative 1. So I could say m minus 4 is less than negative 1. And now I still have to add 4 to both sides to get the m by itself. And I end up with m is less than positive 3. I mean, m is less than positive 3. But if I move this back over here, it looks like I can just combine these two again. Because 1 is less than or equal to m, but m has to be less than 3. So I get this, with an equal to line on that one. And then, of course, I can graph this inequality. All right, so here's 1, here's 2, here's 3. At 3, I have an open circle because there's no equal to line. At 1, I have a closed dot because there is an equal to line. And because this was the combination, the and inequality, I go between. Because m's got to be bigger than 1, but smaller than 3. All right? The other way that we could do this is simply do it all at one time. So if I start with this inequality, I can look at what's in the middle, and I see m minus 4. And I know I have to add 4 to get m by itself. Now if I add 4 here, now that I'm doing this all together, I have to add 4 here, and I have to add 4 over here. I have to do it to all 3 pieces. I have to do it 3 times, because there's 3 pieces here. Okay? Negative 3 plus 4 is 1. Negative 1 plus 4 is 3. And in the middle, I just have an m. 1 is less than or equal to m, less than 3. And that's exactly what I ended up with right up here. Right there. I see it again. And I did it all in one step. Because I kept the inequality together, got the middle by itself by doing, undoing the minus 4 to all 3 pieces. 1, 2, 3. If you have questions about writing compound inequalities or solving them, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.